Guys, remember to look back on your notes. I don't expect you to remember necessarily how to do this kind of thing. I mean, it's been since last Thursday, um, or unless you did some problems over the weekend. But it's why we have notes. So make sure that you have your notes with you. If you don't have a notebook yet, make sure you get yourself a notebook because having scraps of paper around isn't a real good way to keep track of stuff. Give you a couple more minutes to finish these up. And don't forget that it's okay to draw algebra tiles. Good morning.
You don't use your wireless projector, do you?
No, not at all. Haven't come up with a use for it yet. I haven't had time to play with it really.
It's weird because my ThinkPad I think updated because it like got rid of all my user preferences and it won't connect to my wireless.
Oh, that's weird and annoying.
Yeah.
All right. I discovered a little something about live streaming. You know how I rattle this before I draw your name? If I'm standing here and I rattle it, it goes crazy on the live stream. It's like somebody's like beating on the microphone. So I have to rattle less and keep it way over here so that it doesn't impact the video quite as much. Eduardo, where's the vertex of that first quadratic? 4, -2. 1, 2, 3, 4, 1, 2. Where are the next set of points for a quick graph? Over 1, up 1. Nice. Over 1, up 1. Where are the next set of points for a quick graph? Over 2, up 4. Good. So we'll add one more there and then go 1, 2, 3, 4. Over here, 1, 2, 3, 4. And there. Pretty darn nice graph of my parabola. Good. Very good. All right. Let's talk about completing the square. So we'll start with Justin. I'm going to draw my x squared tile. And we're going to walk through it a little bit rather than just get the answer, just to make sure we're all comfortable with it. Justin, how many x tiles go on either side of that? 3 on each side. Good. 1, 2, 3, and 1, 2, 3. Justin, how long is that side of this square going to be? X plus 3. And since it's a square, we've got x plus 3 over here. Now, just a reminder, and if you watch videos on the internet, they're going to do this differently. I am going to write plus 5 way over here. I am not going to use that 5 while I'm completing the square. There are people who really, really like to say, well, I've got 5 and therefore I could fill stuff in. I like to ignore the 5 completely. So now what I've got is, let's see, we got our x squared, we got 6x, and over here we got our plus 5. I guess I don't need to write it up there, but okay, is what it is. All right. Justin, how big is that square?
9 units.
I just completed the square of putting 9 units into that corner and adding 9 units to my equation. Justin, what do I need to do to stay in balance?
Sure.
Guys, notice that this equation is exactly the same as that equation. I've got x squared plus 6x plus 9 minus 9, which is 0, plus 5. This equation and that equation are the exact same thing, but I completed the square by adding and then subtracting 9. So why did I do that? Well, in pink, here's my square. There's my square. Justin, what's another way to write the area of that square other than x squared plus 6x plus 9? How else could I write that square?
Maybe x plus 3 squared.
Yeah, x plus 3 squared base times height. I can write this as x squared plus 6x plus 9, or I can write it as x plus 3 times x plus 3. Either way is perfectly acceptable. The advantage, of course, of that, minus 9 plus 5, Justin? Minus 9 plus 5? So now I'm in vertex form. Where's the vertex, Justin?
I'm not sure.
Daniel, where's the vertex?
-3, -4.
Boom, -3, H, -4, K. -3, -4, and then up 1 over 1, up 2 over 4. Hey, look, there's the graph of y equals x squared plus 6x plus 5. Nicely done, Justin. Thank you for the vertex, Daniel. Guys, are we okay with that? So, here's the next question. I've got a new parabola. And my new parabola equation looks like this. Y equals 2x squared plus 8x plus 5. Go ahead and get the algebra tiles out on this one. Go ahead and get 2x squared tiles, 8x tiles, and 5 ones. And let's take a look at this. Everybody got a set of algebra tiles on their desk? Yeah, good. So once you got the 5 ones, you set the 5 ones off to the side like normal. And let's just focus on the 2x squareds and the 8x. And what I want you to do is I want you to get that square started with 2x squared tiles and 8x tiles. Go ahead and get that square started. How are you going to make a square out of this? Remember the x squareds are the square blue ones? X's are the rectangular blue ones. Don't put a red side up because that means negative. How are you gonna make a square out of this?
Yeah.
Are we seeing the problem? We can't. Because as soon as we put our two x squareds up, we've got a rectangle. And it doesn't matter where we put our x tiles. Put 8 x tiles here. There's 2, 4, 6, 8 of them. This is x plus 4, but this is 2x. It's not a square. It's a rectangle. So here's what we're going to do instead. I want you to build 2 identical squares. Take those tiles, same tiles, 2x squareds and 8x's, and I want you to build 2 identical squares. They need to be the exact same size. 2 identical squares. Tucker, how big you making your squares?
Um,
The drawings are getting a little sloppy here. I gotta slow down. Tucker, what are the dimensions of this soon-to-be square?
X and
Guys, are we okay with that? We want them to be the same size, and why will become obvious in just a minute. So let's make them into squares. Let's fill in these corners. Oh, not here. Daniel, how big are the corners?
4.
So I'm going to rewrite this. I've got y equals, well, I've got 2x squared plus 4x plus 4s. Agreed? X squared plus 4x plus 4, but I got 2 of them. Daniel, what do I need to do to keep this in balance?
Yeah.
Added 4 to this one, added 4 to that one.
Subtract 8.
Exactly. I got to subtract 2 times 4 to keep this in balance. And now, I'm going to bring down my plus 5. You know what? I'm going to change this to green because that plus 4 was green. All right, keep my color coding in step here. This is the point where most people get messed up because they make 2 squares, but then they don't subtract 2 4s to keep it in balance. Gotta remember, you're making two squares here. You're gonna have to add and subtract twice. All right, so what have I got? I've got y equals two of these squares. Well, my squares are x plus 2 squared. Minus 8 plus 5. Notice the only difference is that when I started with 2 of these x squareds, I got a stretch factor. Remember stretch factors from way back exploring quadratics weeks ago? If I have 2x squareds, that means I'm going to have a stretch factor. Am I okay with that? Does it make sense? Again, it's okay to draw the algebra tiles. You have to draw 2 sets of algebra tiles, not necessarily, but you do need to remember that I'm building 2 squares. Should we do a quick graph on this one? Sure, why not? Let's do a quick graph right here. Vertex. Dominic.
Oh. -2, -3.
You asking me or telling me? I heard that question mark at the end.
Telling you.
-2, -3. Good. 1, 2, 3, 4, 5. -2, -1, 2, 3. There it is. -2, -3. Dominic, quick graph. Over and up. How much?
Oh, for the x-intercept.
No. Quick graph. Where are my next 2 points? Remember the
I can't think.
remember the pattern for a quadratic? 1 squared is
1,
2 squared is.
4.
So our pattern is 1 and 4, right? What does that do to my pattern, Dominic?
It screws it.
How?
And you're doing 2 times what you're squaring.
So instead of 1 and 4, 2 and 8. Agreed? Yeah, so it doesn't really screw it up. It just makes it 2 and 8. And that's okay. There's 2. And then let's see, 1, 2, 3, 4. And there's 8. Hey, that wasn't hard. That was really pretty easy, wasn't it? We just have to remember that we got to go up twice as much on our 2 quick graph points, and boom, we're done. We got a quick graph. But we got a quick graph of a much more complicated problem. All right? Okay, here we go. Let's do another example. We'll do this one together, and then I'm going to give you one to do. Let's go 3x squared plus 9x plus 5. So get at your tiles. 3x squared tiles, 9x tiles. And since you already got 5 of the singles out, you can just leave them out. Turns out we don't really need those 5 singles because we know they're just going to be hanging out till the end. But 3x squared tiles and 9x tiles, get them out. How many squares are you going to make? Go ahead and start making them. Identical squares. I've thrown a little bit of a curve at you. You're going to have to think about what we did last week. Yeah, remember you're making 3 separate squares. You can't make one giant square anymore. All right, here we go. There's my first square. There's my second square. There's my third square. As notice, I'm drawing all of them. You don't have to, as long as you can keep track. You don't have to draw 3 of them, but I'm going to draw 3 of them just to make sure that we're all completely clear. So I have 9 X tiles. Luis, how many X tiles does each square get? 3. Okay, so there's 1, 2. Uh-oh. I got 1 tile left, but I can't make a square. What am I going to do? But if I make one of them negative, then I have to add something in. I would have to put in an extra X tile. But remember that we talked about this last week, and that messes up my vertex form because now I got a minus X on the outside, right? I can't do that. So what am I going to do with my extra X tile? Hang on a second. Let me let me draw the rest of my squares here. I have 1 extra X tile for each square. What could I do with it? I could take these and put them down here, but then they wouldn't all be the same size, would they? Eliana, what do you think? Oh, split these in half. Limitation of the algebra tile sitting on our desks. We start with the algebra tiles because we can visualize stuff, but very quickly, we can't actually use the algebra tiles anymore. We have to visualize. But if I split the extra one in half, I get a half here, and I get a half here, and I get X plus 1 1/2. I'm going to write it as X plus 3 halves because it's easier. I took my 3 tiles and I just split them in half. And I do that 3 times. So here we go. A half, a half, a half. Oh, those don't look like a half, but they are. X plus 3 halves, X plus 3 halves, X plus 3 halves, X plus 3 halves. Louise, you cool with that? Louise, how big are these squares? What are the dimensions of these squares? Just tell me the edges. Don't tell me the inside. Just tell me how long are the sides. No, just of the green part. Okay. Okay. I managed to stump Louise, but that's okay. We'll come back and he'll get one later. Xander, what do you think? How big are the sides of these little green squares?
3.
3?
That's like 1 1/2.
Oh, 1 1/2. Those are the dimensions. Remember, dimensions means how long are the outsides, not how big is the middle. What are the dimensions of this room? 30 feet by 30 feet. So, yeah, so you're right. We're looking at 3 halves by 3 halves. We're not adding them, we're multiplying them, right? That's how we get area. Here's a reason why I left this as a fraction. What's 3 halves times 3 halves? Anybody?
4.5.
No. 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 Multiplying fractions, 3 over 2 times 3 over 2. Come on. Come on. You can do it. How do I multiply fractions? Eliana, what do you mean by cross multiply? Because I hate that phrase, but I think I know what you're talking about. Say it again.
3 times 2.
No, that's why I don't like the phrase cross multiply, because you're thinking proportions where you got this and you do that thing. But the words are right. They're just in the wrong order. Multiply across. See why I hate cross multiply? Because we multiply fractions across and we cross multiply proportions. And it's so easy to get those two things mixed up. But this is, Eliana was almost there. 3 times 3 is 9. 2 times 2 is 4. This is 9/4. Which is easier, that or this? This is easier. So we're going to add 9/4, and we're going to add 9/4, and we're going to add 9/4. So what we've got here is we have 3 squares. Each square is x squared plus 3 halves x. No, it's not. Each square is x squared plus 3x plus 9/4. Oh, I want that to be in green. Where'd my green go? It's in my hand. Plus 9/4. Agreed? I didn't lose you, did I? We comfortable with this? What do I got to do to keep this in balance? Amber, what do I have to do to balance out this plus 9/4?
Maybe.
How about this one?
Maybe.
How about this one?
Maybe.
In other words, I've got to subtract 3 of those to keep it in balance. And, oh yeah, I had plus 5 on the end. Guys, are we good with that? Other than the little tricky part about multiplying 3 halves by 3 halves, are we okay with the completing the square part? We made 3 separate squares, one for each of our x squared tiles. Each of these x squared tiles had 3 x's, so we split them in half and put 1.5 on each side, or 3 halves, because we just took our 3 tiles and divided it by 2. We filled in the corner with 3 halves by 3 halves. We subtracted 3 halves by 3 halves to keep it in balance. And we did that 3 times. So let's look at the equation that we get here. Y equals 3 times. Well, how big is this square? X plus 3 halves squared. That's the square right there. One of them. And we have 3 of them. 3 times 9/4. Should be able to do that in our heads, because this is really 3 over 1 times 9 over 4, right? Eliana, what was the rule for multiplying fractions? Excellent. 3 times 9 is 27. 1 times 4 is 4. And you know what? Because I want to combine these two numbers, I might as well make that out of 4s as well. 5 is how many fourths? 20. Yeah, because I'm just going to multiply that by 4 over 4. So combining those, I get y equals 3 times x plus 3 halves squared minus, well, 27 negatives and 20 positives gives me a leftover of -7. Guys, this is a complicated one. I never would have figured that out. But with completing the square, the vertex is at -3 halves, comma, -7/4. And it has a stretch factor of 3. 1.5 is right there. -7/4 is not quite 2, so the vertex is here. This is a complicated one. Hard to do a quick graph on this one. It can be done. Where's my second set of points? Someone want to volunteer that one? Over 1 up what? How much? 3. Over 1 up 3. And now I'm going up 3 from, I'm going over 1 from like a weird spot, 1.5, but that just takes me to a half. And I'm going up 3 from -7/4, but I can just count 1, 2, 3. So it's going to be a little bit above 1. It's going to be a quarter above 1. And then symmetry says, oh, look, there's another one right there. Hey, you know what? I'm just going to stop there. And if I were on grid paper, what I would notice is that my point is sort of like in the middle of one of these squares. It's above a little bit, in the middle sideways. A little more complicated to graph, but the process wasn't that difficult. The process was just split everything into 3 to make 3 squares. And this is how I know every single time. How do I know how many squares I'm going to make? I'm going to make that many. Number of squares. So I'm going to give you one. It's going to take a little bit of time, but that's okay. Be patient. Keep track. Don't lose track of anything as you're working your way through it. If you want to start by laying out the algebra tiles, that's fine too. Because I'm going to give you y equals 4x squared plus 16x plus, let's not do 12. I don't like that one. I don't like that. Let's do plus 11. And remember, these squares are all identical. You don't have to draw all of them. You could draw one set square, and then just remember that everything you're doing, you're going to be doing more than one time. So I'll give you a few minutes to work on this one. Very nice.
If you're making four squares, how many does each one get? Yeah, so that shouldn't be eight, right? That should be four x's.
Yeah.
Instead of eight. So then don't wait a minute, you're just writing four x right there. Now let's think about your squares. I agree with you, you're adding four to each one. But how many times do you have to do that for? Yeah, because you gotta make one three a square, right? So that should be a minus four times four instead of just a minus four.
Oh, okay.
Now, this is a square, right? Let's actually build this square. Let's just build it. So I agree with you. Ignore these, it's all the same. I agree with you. This is the correct square. But we're not gonna write this as x squared plus four x down here. What are the dimensions of how big is that square? Think about left times width. All squared, right? So in that parentheses, what you want to write, you actually want to write x plus two with the squared on the outside. So get rid of that square right there because that's not. It's not an x squared. Does that make sense? This whole parentheses here is that square. And that square is x plus two by x plus two. Cool. So, question for you. You added four, how many times? Four times. So what are you gonna subtract? Yeah. Little thing, but you only subtracted it once, but you added it four times. What, do you have to divide 11? Remember what I said about the plus 11? I said ignore it, set it off to the side. So how much are we putting? Let's just let's focus on one of these squares, because they're all gonna be the same, agreed? How much do you need to put in there? Because we're ignoring the 11. What do you gotta put in there? Good. So you need to put four of those in here. Okay? Now, what are you gonna do to keep it balanced? Well, you could, but really what we're trying to do is we're trying to balance out this plus four. We'll deal with these ones in a minute. How do we balance that plus four? What's the opposite of plus four? Ready to put that on the outside? I mean, because those cancel each other out, right? That makes it a square, this cancels it out. So when we write this, what we've got is we've got an x squared plus four x plus four. That's my square. Minus four, agreed? The 11, we just set off to the side. Now, how many times do we have to do this whole thing? Four times. We got four of these squares. We got four of the balances. Is that cool? Yeah, so see if you can fill out the next step. Oh, and you just were fixing it because it's gotta be four times. Yes, absolutely. Good. I'm not a big fan of this. Here's the problem. 4 times 16 is actually 64. What you really, pencil.
Oh, is it just four?
Yeah, because you put the four, you added four to each square, but you did it four times.
and then that's balanced out by the -16. So your answer's correct, but that's just one thing right there. If you really put 36 in, or 16 in there, you would have had to actually subtract 64 on the outside, but then it wouldn't have been a square, so.
Wait, no.
No, that was right. Okay. It was just the inside part that was, you just had written the wrong number in there. Yeah, so everything else is correct. Okay. Oh, that would be good.
Yes.
Wait,
That's the wrong.
yeah, where's the problem that we're working on here? Right there. Okay, what does that say? Okay, nope. Here's the problem. Each of your x squareds has 2 x's on it, right? Or has 4 x's total. So you're not, if you think about the process that we've done up on the board, we've got 1 squared here that is x squared plus 4x plus 4, agreed? And we're doing that 4 times. That 4 has to come out of the parentheses, and then this is a single square. This is your square right here. Okay? Now, y minus 7. Yeah, but that's why I hate that process. That's why I hate the get the 11 thing, which is what you saw online. That's something I ever told you. Because here's what we really gotta do. If we added 4 times, what do we have to subtract? We have to subtract 4 times. So this really needs to be a -16. And then when we combine them, that becomes a -5. And this doesn't become a -4 because how big is this square? X plus.
Oh, see.
Oh, so then we want to write it like this, x plus 2 squared minus 5. And now we can go to the vertex. Yeah, cool. Yeah, it does. I like it. Cool. Good job. Yes. It is. Excellent. All right, guys. So, making 4 squares, agreed? I'm going to draw one of them. How many x's does each square get? Anybody? 4. 1, 2, 3, 4. How much do I need to fill in? Ow! Stupid mask just poked me in the eye when I was shoving it around on my face. Ow. Okay, hang on a second. I'm going to take this off for a second and look at it. Okay, no. I wanted to make sure that little piece of wire that pinches around your nose wasn't sticking out. It just jabbed me in the eye. But no, it's not sticking out. So it was just weird. Okay, sorry. That was a distraction. How much do I have to put in here? +4, 2 by 2. This is a 2 by 2 square. That little corner. So I'm adding 4 to make my square. Here we go. How many squares was I making? 4 of them. What do I have to subtract to compensate for that little corner? I have to subtract 4, but how many times do I have to subtract 4?
4.
4 times, once for each square I made.
And then I bring down my plus 11. Guys, notice that this is plus 16, balanced by the minus 16. Always got to remember that whatever we're balancing with has to be done for every single square. Now, here we go. We can write it in vertex form. Y equals 4 times. How big is that square? How long are the sides of the square? X plus 2 by x plus 2, which means this is an x plus 2 square. Minus 5. My vertex is at negative 2 comma negative 5, and I have a stretch factor of 4, which means that if I were going to do a quick graph on this baby, 1, 2, 1, 2, 3, 4, 5. There's my vertex. Over 1 up how much? 4 instead of 1 because I got a stretch factor of 4. So I go 1, 2, 3, 4. And symmetry says there's another one over there. Over 2 how much? No, there's a stretch factor of 4. What do I got to do to add 8? No. Yes. He said 8. And then I was thinking, no, you got to multiply before that's 32, but you multiplied it by 2, didn't you? I missed that because you would have gone 4, right?
Yeah.
But you doubled it instead of, so we got to go up 16, yeah. Oh, wow. Let's see about 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wowzers. There it is. Boom. There's our quick graph. This is a tall, steep parabola. But it's 4 and 16 instead of 1 and 4. So it's still easy. Just means we had to do a whole bunch more bigger graph. We cool with that? Guys, let's look at a couple patterns. Things that maybe we have noticed. First of all, have you noticed, we'll use different colors, that we always divide this by the number of squares? So we took our 9 and we divided it by 3 and we had 3 per. We took our 16, we divided it by 4 and we had 4 per square. And then we divided it by 2 again. Because after we knew how many went per square, we split them in half to go on each side. So if we were going to generalize this a little bit, just to sort of help us keep track, here's what we might say. This board is wet. Hang on. Dry more. Do I want to generalize? You know, it's not. Why don't we just do some more practices? Because I've got a classwork worksheet on Google Classroom. And the classwork worksheet is called 2A. Because tomorrow we're going to talk about a new topic. We're going to be using quadratics in modeling something. So I made up a quick worksheet that's got 4 more of these with a number out front.
Here's what I'd like you to do. We've only got 11 minutes. No, wait, yeah, we've got 11 minutes left because then you're gonna be going to homeroom. Why don't you pull up the worksheet on Google Classroom and try to get the first two done? Do not do the second two. You're gonna do the first two and turn them in for me, okay? I made it 4 because I wasn't sure how much time we were gonna have. So the first two, number 1, number 2, and turn that page in to me. Any questions? All right. Thank you. I'll hold it for you, and that way tomorrow. All right, I'm gonna go ahead and shut off the live stream.